Hi, everyone, and welcome back to Networking Fundamentals. This is Instructor Gregory, and we're about to start with Module 3, Defining Networks with the OSI Model. All right, so let's do a quick overview of our agenda. All right, so we'll be discussing understanding the OSI model, and we'll talk about the different layers of this reference model, specifically the communication subnetwork and its upper layers as well. We're also going to be reviewing the TCP/IP model later on in this presentation, okay? But first, we're going to discuss layer 2 switching and layer 3 switching. Now, all of this layer discussion will make a lot more sense after we review the OSI model, all right? And that's why we're going to review both of these objectives together. All right, so let's talk about layers of the OSI model. Now, standards are a set of rules that ensure that hardware and software that are released from different companies work together, right? They provide us the infrastructure in which we're able to develop hardware and software, again, that works together. And there are a few organizations that coordinate these standards. Now, you may have already heard me reference one of these, the IEEE, which is the International Electrical and Electronic Engineers, right? Now, they focus on electrical and electronic fields, right? But we also have the International Organization for Standardization, and it's called the ISO. Now, that's not actually an acronym. That's actually their name, ISO. So keep that in mind. It's not a misspelling on my behalf. I strongly recommend that if you're really serious about establishing a career in networking, take some time, go ahead, look up these organizations and learn what they do. All right. Now, you're going to commonly hear these standards referred in the same breath as protocols, but protocols and standards are a little different. A protocol, okay, is a clearly defined rule and procedure that allow different manufacturers to create hardware and software that work together on a specific layer. So what are layers? Well, layers make up the OSI model, and the OSI model is just a means of simplifying the complicated process that occurs during networking. So we talked about how data was transferred in a previous module, right? And this model, the OSI model, allow us to follow along with that process and understand which protocols belong at which layer, right? What's also cool about the OSI model is that if we design any kind of software or hardware, we can pick and choose which protocols we want to utilize in order to accomplish specific tasks, right? The protocols that we choose have no impact on the layers, right? Let's say I'm designing something for the presentation layer. Okay, that's the layer 6, right? The protocols that I use on the presentation layer have no effect on layer 5 or layer 7 or anything else. It's completely modular. I can trust that layer 5, layer 4, 3, 2, and 1 are all going to do their intended jobs. All right, so let's talk about how the layers function. And I want you to take a look at my model that I have here presented for you. Now, there's data at the application layer, presentation layer, and the session layer, right? And then at the transportation layer, something interesting happens. Data is broken into segments, which you've heard me reference previously, right? And then at the network layer, that segment turns into a packet because additional information is added. Okay, and then ultimately at the data link layer, the packet becomes a frame. All right, and then we reach the physical layer where that frame is translated into bits and then transferred across the network. All right, so let's go back to the presentation and talk about the first 3 layers, the communication subnetwork. The communication subnetwork is made up of the physical layer, the data link layer, and also the network layer. Now, this is like the underworld that makes up the internet, right? Layer 1, the physical layer, just defines the electrical medium for data transfer. Well, not necessarily the electrical medium, but the physical medium. You see here, I noted that physical layers components are like your cables and your jacks and your patch panels and your punch blocks and your hubs. Okay, now we're going to discuss physical layer concepts, and we'll talk about, we've talked about topologies, right? We talked about serial data transfer. So go back and review your notes about that, right? These are your physical layer concepts, right? And we're going to touch on baseband versus broadband, and also talk about analog and digital encoding as well. All right. Once again, I want you to note that the unit of measurement here at this layer, this physical layer, is bits. Ethernet standards, like we mentioned in our previous modules, define the communication method for high-speed data exchange amongst devices. And you're going to commonly see that the technologies here are referenced in this particular format. 100 base T is an example. All right. Now, 100 is for megabytes per second. All right. And if it was gigabytes, it would be 100 with a capital G. Okay. Now, base is short for baseband, which is a technology that we're going to detail in a little bit later. Now, T stands for twisted pair cabling, so that we know that the medium being used is a copper wire. All right, so I want to review that just a little bit. Write this down. I want you to make a special note of this. 100 in this case, okay, stands for megabytes per second. The base is short for baseband, and the T is for twisted pair cabling. All right, now let's move forward. As bits move up the stack from layer 1 to layer 2, they're going to become frames. The data link layer is going to establish, maintain, and decide how transfer is accomplished over the physical layer. So it's going to prepare your data for transmission on that physical layer. All right. The data link layer components are your network interface cards and your bridges, which are technology we're going to talk about a little bit later. And the unit of measurements here is frames, okay? Now, the data link layer is responsible for making sure that data is transferred properly and that there aren't any errors that occur during the transmission process, okay? So when the device on the other side receives the data, it's whole and it's prepared to turn into beautiful files that we see on our screen. All right, so something really important here is MAC addresses. MAC is short for Media Access Control, and every single network adapter on an Ethernet network has a MAC address. A MAC address is similar to your fingerprint, right? They're unique identifiers. And all of us, you and I, have fingerprints and they identify us as unique individuals, right? Well, network cards are very similar in that regard, okay? They have MAC addresses which identify them as a unique device or as unique devices, all right? Now, a MAC address is 6 octets in length and is written in hexadecimal format. Okay, now hexadecimal includes 0 through 9 and then A through F. So you have 16 characters there if you include 0 through 9 and A through F. So that's all 16 characters. And then notice here in my example, there are just 6 octets. Okay, each pair of hexadecimal character represents a byte, so that's 8 bits, right? Now, the first portion of the MAC address typically represents the manufacturer. Okay, and then the second portion is going to be unique to the device. Okay, it's also important to remember that sometimes we call the MAC address a physical address as well. Several times during our presentation, you may have heard me say the physical address of the device, right? And I'll be using those interchangeably. So whenever you hear the word MAC address, think physical address. And whenever you hear the word physical address, think MAC address.